So we're a few hundred meters down from Crag Hall flow gauge, and we're on a stretch of the Ouseburn here with a little weir and a nice straight stretch of channel. And this is where each year we come with the master students to do the flow gauging. Now I've stopped here because this is a perfect place to pour in our salt concentration for dilution gauging. Here you can see we pour some known quantity of salt in, and it would be very mixed, and then we would actually measure the conductivity of the salt further downstream, and then we would convert that conductivity to milligrams per litre of salt, and the dilution ratio would give us the flow. So I'll just move downstream a little bit. So this bit here with all the stones and the well, it's quite deep today, but usually the water's very shallow here, so you wouldn't be able to get a flow gauge into here, a velocity meter, so you would use salt dilution. However, if you do move downstream, on this nice stretch, health and safety at all times, we'd get a couple of teams in here with a velocity probe, and we'd actually make measurements of velocity going across. Then we'd integrate that to give us the total flow. The third method we do is kind of Manning's equation. Oh, there's a nice little bird. So for Manning's equation, we also need to know the cross-section to work out the hydraulic radius and the wetted perimeter, but we also need to know the gradient. So we would set up some surveying right at the top there and run for a couple of hundred meters down to the bottom and get the gradient of the bed. And then, so we'd have three ways of doing measurements: salt dilution, velocity area. So I'll show you some photographs of our team in the river shuttling across and making lots of velocity measurements. And what we then tend to do is record the time, and then we compare it against the Crag Hall EA flow gauge.